Hello, good evening, everyone. My name is Fadi Saad. I'm a co-founder of MassRobotics. I'm the VP of Strategic Partnerships, and today I have the pleasure to kick off the GM MassRobotics Gripper Challenge. So I just want to start off by giving you a quick background about the relationship, which started last year with GM. And the key motivation was GM wanted to tap into the mass robotics ecosystem and cluster and really looking at innovative solutions for some of the technical challenges they have and how they can tap into some of the innovative companies in the ecosystem. And we announced the partnership last year, and since then, our teams, both from GM and MassRobotics, have been working very closely in order to develop and shape this challenge. The genesis of this challenge, I know that GM will share more about it, but I have to say that I was impressed with the need and the kind of the specification that GM came up with. And it's really a unique challenge, and we are looking at developing something that does not exist. And I remember in some of the early discussions, I was kind of suggesting ideas and companies in the space, and I remember Pat saying, no, Fed, you don't understand. We have looked all of that. This is not what we need. What we need does not exist. So this is a truly innovative and a unique challenge. And I'm happy that we have lots of interest from our companies and the stars of our ecosystem who are interested to join. So I hope that together we can really solve this tricky and challenging technical problem, and hopefully innovative companies will come out of it. And as you know from previous challenges and ongoing challenges that we have organized, we don't do typical challenges, and we don't necessarily looking at the financial or kind of cash prizes and taking pictures and all of that. We are in the business of forming and scaling the next generation of innovative robotics companies. So the real opportunity here is companies who will win this challenge will have the opportunity to work with a world leader company like GM and a tycoon in the US manufacturing. So this is the real opportunity, and this is the real prize, in my opinion. Before I hand off to Pat, I want to acknowledge the amazing work that our team have done. Tom Ryden, our executive director, have been always supportive, and he provided all the resources and all the help that we would need to make this challenge and this partnership a reality. Joyce, our VP of programs and community, have been doing a fantastic job in putting together this webinar and all the kind of background kind of work. Russ, who recently joined my team and partnerships, have been doing a phenomenal job, and really he's the one who have been doing the heavy lifting and working with GM team in order to refine and develop the whole process and the whole tools and approaches that we would be using. And I'm sure that you will be communicating with him more as we go through the process. And finally, I want to thank the GM team for their commitment, dedication, and support. And let me introduce the representatives of GM today that we have on the call. So Miguel, he's a senior researcher in the manufacturing systems research in GM R&D. Bob, he's the manager of the GM Global Innovation, and he has been our key contact and really the key driving force behind this partnership. Alec, he's an analyst working with Bob and the Global Innovation team. And last but not least, Pat Spicer, he's the chief technologist in the manufacturing systems research in GM R&D. And Pat will be the one that will tell you more about this challenge. Pat?
Well, thank you, Fadi. Thank you for that very nice introduction. And yes, we really appreciate working with you and MassRobotics, and appreciate all your efforts in pulling this together. We're really excited about this challenge project, and in exploring this method of innovating. So yes, I'm part of manufacturing systems research at General Motors Global Research and Development. Our goal as manufacturing systems research is to develop new technologies for our manufacturing operations to improve cost, quality, throughput, or to help us produce new products that we haven't produced before and produce those at the high volumes that are typical for automotive production. So we're a little bit different than the rest of R&D that is focused on product innovation. We're the one part of the organization that is really focused on the manufacturing process innovation. We're excited about this challenge today because it's really going after a key area for us that keeps becoming more and more important for us, and that is to enable flexibility in our manufacturing processes. So that we can adapt our manufacturing processes to produce new products more rapidly with less cost and to change over to new products. Competition is always increasing. Production volumes are lower today than they were when the automotive industry started, and the trend continues in that direction towards a greater variety of products being produced at lower volumes. And we see many changes taking place in the automotive industry as we look at vehicle electrification and the changes to our products that are a result from that. We want to be able to adapt quickly to those changes. And a big portion of adapting quickly to those changes is due to our manufacturing systems and our ability to spend our capital investments wisely to adapt to those new products. So that's where the importance of flexible operations, flexible equipment comes into play for us. And this particular challenge project is going after our ability to be flexible in our robotic systems for processing in our body shops, and specifically for gripping parts in the body shop. And we've seen where other companies have had similar challenge projects in the last couple of years in this area, focused on, let's say, warehousing logistics types of operations or pick and place, maybe packaging operations. Ours is a little bit different than that. Those solutions that may work in that space, they will not work in the space that we're operating in. We're really looking at handling of sheet metal components, but not just picking them and placing them, but also holding them for processing and for precision processing, and doing that in an environment that's more harsh than a typical warehousing operation. And that's where we're looking to open this problem up to smart startup companies, clever startup companies, and other organizations, universities, to see what creative ideas you can develop. We look forward to seeing those solutions and hopefully finding a solution that meets our needs, or will at least meet part of our needs. So I've got with me Dr. Miguel Saez, who's he's also online, and he is my lead researcher in this area, and he's going to help with a lot of the technical questions. But I'm going to step through a quick presentation on this. And Fadi, will folks be able to ask questions while I go through this, or should we hold the questions to the end?
I would say feel free to send the questions over the Q&A window, and Russell, he will be kind of consolidating all the questions, and after the presentation, he will basically run us through the questions.
Okay, great. Okay, so let me get started here. Okay, so as you all know, we partnered with MassRobotics, and we're having this challenge to reach out to multiple different organizations, startups, academia, and integrators to develop a proof of concept universal end effector that's capable of grasping and holding a large variety of sheet metal components for the purposes of precise robotic assembly. Yeah.
I'm sorry. I just want to make sure that everyone is seeing the screen. I have some people not able to see the screen. Joyce, Russell, is there a way to kind of get thumbs up on seeing the presentation?
So yeah, if you're having difficulty, if you go up to use two screens, also there's some everybody should have some options to see different screens, but it's a personal preference. So if you are having some difficulty, just play around with the options at the top of the screen.
Also, you have to have all of your other applications closed and the window will pop back up. Sometimes it's hidden behind another application you have open. It's best to have all applications closed while you're watching.
Sounds good. Sorry, Pat. Please.
Okay. Okay, sure. No problem. So we're trying to develop a proof of concept universal end effector. The larger the number or larger the variety of components that the end effector can handle, the better. The end effector must be capable of holding the parts firmly enough to enable precise part positioning and alignment, as well as processing, which in our body shops typically means resistance spot welding, but it can also mean placement of adhesives or other sealant materials, that type of thing. The key metrics that we're going to be looking for include flexibility, holding force, cycle time, the time that it takes to reconfigure the end effector, reliability, simplicity, and cost. So I want to show you, I think many of you are familiar with automotive manufacturing to a certain degree, but I wanted to, since I can't walk you through a plant, I wanted to kind of show you some videos virtually here that give you a flavor of what it's like in a body shop environment. So hopefully this will work. And these are videos that are publicly available if you go to our media site. And Russell or Fady, let me know if there's any trouble seeing this video image. I'm going to walk you through here.
I can see the video. I hope the rest of the participants can see it.
Okay.
Yeah, if you have any problem, just send us a message on the chat box.
So this is what it looks like in one of our body shops. This is for our Fort Wayne truck assembly plant, and this is where we're producing the sheet metal body structure of the truck, and you can see it in a certain stage of buildup. It's not complete in this stage, and this would be a sub-assembly cell, and you can see the sparks flying. That's expulsion from resistance spot welding. And so parts are being held together in fixtures while they're being welded with resistance spot welding. And you can see various robots working to either do welding or to move parts around to different positions to place them into fixtures or hold them against the vehicle. You can see that this is a harsher environment to be in than your typical warehousing operation, especially those that hot metal can be destructive to to certain materials, especially materials that are flammable. Here, actually, if I back up quickly here, you can see a typical end effector in orange at the end of this yellow FANUC robot that's holding a larger sheet metal component here. And that's typically how we build them. It's dedicated to a single style. It's a steel structure made out of steel tube. When we're done producing this particular style of component, we'll need to throw away this end effector and buy a new one. And that means designing a new one and building a new one and trying it out and making sure that it works. And this is something that we do times every single robot and effector, and times hundreds of robots in a body shop in a plant. And we would like to be able to do that with a flexible solution so that we can reuse our capital over a larger number of parts. Are there any questions at this time?
At the moment, there's not a bunch, but feel free to post in the chat or send a question directly.
Pat, this is Miguel, and to the team here, just a quick comment about what you're seeing. As Pat mentioned, Pat, if you can just go back a little bit on the video, you see a lot of expulsion on the parts. So that is mostly carbon with a little bit of metal. So for the harsh conditions in which these robots operate, some solutions like magnets are, it's not that they're prohibited, but they're try to be used less often and to a minimum, because sometimes that could magnetize the part, and then the part could attract those expulsion particles, which would be a defect after paint. So you know, given given the conditions in which this robots operate and the end effectors will operate, some conventional gripping solutions like magnets are not preferred. Similarly with vacuum, you know, you can see that expulsion dust, vacuum could tend to get clogged or not have the proper suction or vacuum when the part has oil. Sometimes the parts in automotive as they come from the stamping facility have some oil or rust preventives, so that could affect the performance of vacuum or suction based gripping solutions.
So yeah, we do have two questions here. One is regarding that. So you mentioned that there will be electromagnetic grippers are a little bit not in certain situations. They might not be the best with the welding. But someone asked, should we assume that also non-ferrous materials must also be handled?
Yes, that is correct. That would pose additional constraints. At this point, the parts that for the final phase that we will be using are all ferrous, and a magnet will hold them. However, in terms of as we evaluate flexibility, a gripper that it's able to hold ferrous and not ferrous materials would have a higher score, because we would have the flexibility to hold like steel and aluminum with it. So I think that answers the question.
Okay. And another question is, what is the typical weight of the objects?
So the weight, as you can imagine, it varies. You can think that from let's take it from what you're seeing right there. That is probably a part of an underbody. It's around the object itself. It's around 20 pounds at most. Some smaller brackets, which is the focus of this work, would probably be 5, maybe 10 pound stops, maybe probably less than that. But I think that we have on the specs, I think we have a reference for weight, but for brackets, small brackets, which is what we will be holding here, it would be less than 10 pounds.
Yeah, I know. I think in our call out spec we mentioned 25 pounds, which is a good tolerance to have too, if they're 10 to 15 pounds.
Yeah.
One of the things we think about also in terms of ability to hold a part is if the robots are moving quickly and for some reason there's a power outage or there's an emergency stop button that's hit, we want to make sure that the robot end effector is still hanging on to the part, that the part isn't released you know, so that things are safe. And we're also interested in an end effector that can allow us to hold the part while there's some processing being done. And so there may be additional forces applied to the parts or additional loads due to processing.
Okay.
So just to break it
I've got
up.
another video that shows maybe some examples of some smaller components here that we can also show.
Well, Pat does that. You can think that there will be 3 loads or 3 different. The end effector will see 3 different types of loads. One is the part on a static condition, just we're holding the part. The other one is dynamic. Well, you're moving the part from point A to point B. And the third one will be where at point B you might be pressing the parts against each other or against the fixture, applying a certain force. So they were for that. The worst case scenario for this challenge out of those 3 would be 25 pounds, as you mentioned, Russell.
All right. So we have another question. It's a bit. I know this is probably a tough one, but I guess broadly. So what are the typical dimensions of the end effectors that you're looking for?
So for the reference parts that we will be using are, you can imagine that they all fit on a shoebox or shoebox size brackets, if you wish. Some smaller, kind of like the ones that this lady is holding in her hand. So we don't necessarily want to constrain solution for the size of the end effector. However, again, we will be evaluating simplicity, and that could be tied to the packaging of the solution. So I don't think that answers the question directly of do we have a constraint on the size of the end effector? So no, but I don't think there's a limit, but we are considering that an effector with a better packaging and a leaner solution will get a higher score. And we do have as a reference that the parts, you can use it to think that the parts that are going to be handled by the end effector can fit on a shoebox. They're like 30, 35 centimeters long.
Something like that, on the order of the size of this part, is our greatest interest right now. We've got, basically, I think we could say we have a larger variety of these smaller components than we do the larger panels. Although if we had a solution that would handle the larger and the smaller components at the same time, that would be great.
And then one of my questions really quick too. So are you guys interested in having kind of like a scaled approach in which like maybe someone comes up with a gripper that is essentially the same design, but it's just a different scaling of, bigger to small?
Yeah, that's a great point, Russell. And I think that the answer is yes. I think that more than the specific design and for holding parts A, B, and C, what we would what we would be evaluating is how are the parts being held, and can that same gripping strategy be scaled up or just done at a larger scale, right? So if all it is take the same solution and put it on a bigger frame, and now you can handle bigger parts, that would definitely be an advantage.
Excellent, excellent. We have a few more questions too. We got a bunch. There's one. So are there defined 0 points for each part, and what are the tolerances for the parts?
So there are no so the parts. I don't know if this answers the questions in terms of zero for the parts. Usually in automotive applications, typical holding strategy, it's a two-way and a four-way locating strategy, that is a pin and a slot. However, you could have on a part 2 pins, or you could have a part that it's blind. So again, flexibility will dictate how the parts would be a major driver for how the parts are being held. So in that regard, there is no 0 point on the parts that we have to maintain. We have to be able to assure that the parts don't move once is being held by the end effector. But the position, the relative position of the part with respect to the end effector could change from design to design, from part to part, right? So I don't know if that answers the question.
Yeah. Okay.
Well, maybe I could add to that a little bit, Miguel, as well, is that in general, we do add features to our parts that help us to locate parts into fixtures. Like you can see here, these parts are being placed onto a fixture, and they're typically being placed over some pins that would go through some holes in the part to make sure the part is positioned properly. And then there are certain surfaces on the parts that we have details in the fixtures that touch against to make sure that that part is held in a certain orientation on a certain plane. So many of these parts will have these features in them. In general, we do want to know the position of the part in the end effector relative to the coordinate system of the robot. There's a couple ways that you can do that. One, you can do that physically by, let's say, pinning, using pins through holes in the part, or you can do that by holding the part firmly and then maybe like showing it to a camera, and the camera is telling you the position of the part in the end effector.
Yeah, I believe that answered the next question, which was basically how is the end effector currently holding the panel at specific points if it's not vacuum or magnet. So you have the pinhole and surface contact locking, it seems. All right.
So yeah, we could go back to the other video that shows more of the end effector approach. But yeah, we're using hard clamps typically to hold the part in position with our end effectors that you see in production today.
Now, so this kind of goes with the video right now. So this question, where are the parts being picked up, and are they stacked and have to be separated, or is this handled by the robot?
So the parts will not have to be picked up from any bins. Right now, so correct me here, Pat, if I'm wrong, but the parts will be presented to the end effector on some sort of like presentation nest that will put the part in like a single part on the right orientation. If a solution that can handle random bin picking of the part is presented, that would definitely be a plus.
Yeah, I think that's probably a good way to answer it. To get to the robot, the parts need to come from these shipping containers usually, and so oftentimes, as you see here in the video, we have a person that transfers it from the shipping container to a fixture or to a position where a robot can pick from. But yeah, solutions that can do that picking from a container for us, and even if the part is in a randomized positioning in the container, those would definitely be ones that we would look at more favorably.
Okay. And so I think, there's another question. Just briefly, can you touch on why magnets are not preferred?
Well, maybe Miguel, you want to talk to that? I think,
Yeah.
I don't know that we want to exclude magnets, but you can maybe talk to just the specific challenges around them.
Yeah, sure. As I mentioned before, two main issues with magnets is that they could magnetize a part, and then the part would attract some of the particles, expulsions, for example, from the welding operation, which would, as the vehicle goes to paint, they get painted over, so that is a quality defect if the part has a lot of expulsions embedded into them. Also, sometimes what, not that, I mean, that these comments come from experience, that the magnets end up, either the part attracts the particles or the magnet itself attract the particles, and then it's possible that you start building up material on the magnet surface, and that affects the performance of the magnet, like the holding force, or they end up scratching the surface of the part. So that is on the part side, and then on the other aspect is flexibility. Then if a solution only relies on magnets, then that means that the effector can only hold ferrous materials like steel, and with the current pursuit of lighter structures in the vehicles, we're starting to use more and more aluminum or even carbon fiber, but for the most part aluminum in our bodies. So not relying on magnets would be an additional point for flexibility.
Okay. So we got a bunch more questions we gotta run through. Another question is, so is there a minimum or maximum number of gripper elements? For example, 1 to 3 touch points working together?
I don't think we'd have a maximum or a minimum. We want to be able to constrain the part in space and do that in a flexible way. We want to avoid too much complexity because these have to run for years. We don't want them to break down easily. We want them to be easily maintained, and we want them to be we don't want them to be too costly. Although if they're flexible and they can be reused, we can afford maybe a little more cost than we could for a dedicated end effector.
Okay. Let's see. We have another question. I'm not sure if this means the so they're asking about the IP protection level of the robots. So perhaps kind of what level of security would need to be maintained working on this system.
IP protection of the robots.
So I'm not sure I understand the question completely. I think that the participant will maintain their IP in the end effector if it's their design. The rest of the components that we're using in our system for automation are off-the-shelf components. So, and things I think that whatever is, background IP, if you wish, that either GM or the participants bring to the table will be their IP.
Yep. I think maybe they're just, I mean, generally interacting, once we, groups that are chosen, that obviously there'll be an NDA agreement need to be signed, standard stuff. So let's see. So are you looking to have mixed handling? Meaning, how should the end effector be able to change between different parts? Sorry, how quickly should the end effector be able to change between different parts?
So I would think that that question could have two answers. So in terms of how, I mean, some actuation, it's permitted. I think, and actuation is what you could think that you can move a holding fixture with a motor, a servo, or a mechanism, or even pneumatic solution and a mechanism. In terms of how long it takes to change from one model to the next, we don't have a specific requirement. However, as Pat said, cycle time would be one of the evaluation criteria. And as a reference, right now, if we were to change the end effector from holding one part to holding another part, you can see from the video that, if you could do that reconfiguration in the air while you're holding part A and now you're holding part B, that usually takes a few seconds. So I want to say probably 10 seconds or less.
Okay.
Right.
Mm-hmm.
Okay.
So I just want to, looking at the time here, and I want to make sure that we go through all the materials. So I'm sure that we have lots of questions, and there will be an opportunity to send questions through our website. But Pat, I don't know how many slides you still have left, but if we can go over this quickly, and then if we have time for more questions, we can definitely do that.
Yeah, and I think Fady, we probably covered a lot of what we were planning to talk about. I just got
sure.
I think we've talked about the requirements. We've gone through most of these points here, and in terms of performance, what we'll be judging on: flexibility, holding force, or ability to constrain the parts. Not just to be able to hold the weight, but also to be able to hold the parts for processing. So to be able to withstand some processing forces, not something like a machining load or something like that, but something like if a weld gun comes and interacts with the part, generally the load should be balanced out in the weld gun itself, but there can be a little bit of a mismatch in positioning, and you tend to pull the parts a bit to one side or the other. Speed, I think we put 5 seconds here, Miguel. You said 10 seconds. As you can see that, we want to be able to minimize that changeover time from one part style to the next. A few seconds, I think, is kind of what we're thinking about. Obviously, the less time, the better. So something that can reconfigure or change the production style or the product style automatically or programmatically would be something that we would want to have. We want a reliable solution. It's got to run for cycle after cycle. That means thousands of cycles per day, times hundreds of days per year, so hundreds of thousands of cycles per year, ideally without failure or with a minimum number of failures, and easy to repair. So long time between failures and short time to repair. We're looking for simple solutions that people can understand in the factory, not too complicated. And we also, something we haven't mentioned is we're looking for solutions that provide accessibility to the part. And so there are some flexible gripping concepts out there that you've seen that do sort of envelop the part. That can be a problem for us because we may want to have more accessibility to different areas of the part. So the more accessibility or more open that we leave the part for other processing or for mating with other fixtures or parts, the better. We don't want to envelop the part completely. And ideally, this would be a solution that grips the part from one side, not from all sides. And then cost. We want a low-cost solution. We want to minimize our investment. But if we really do have a solution that is more flexible and can be adapted to multiple styles, then that will save us cost over purchasing additional dedicated gripping systems and throwing those away. And so we might, I could see where we might be willing to spend more for this flexible solution than our current dedicated solutions. We're also hoping that if this is a solution that we can use in many of our robots, that there might be some benefits gained in terms of economies of scale. So instead of purchasing just one end effector of a kind and designing that specifically for a certain task, we might be purchasing, let's say, hundreds of flexible end effectors all with the same design. Maybe there would be some benefit in terms of economies of scale due to that. The last slide here, really we wanted to talk about some limitations of existing flexible grippers that we've seen out there. We've seen some solutions that are very flexible but don't provide the precision that we need, so that we know that we've got the part in the position that's needed, and that could be, that's typically precision on the level of, what would you want to say, Miguel, less than a millimeter? Less than a half a millimeter?
Yeah, correct. I think
ideally 0.1, maybe 0.1 millimeter, tenth of a millimeter.
Yeah, and I think less than 0.5 millimeters would definitely be preferred. Preferred, and you know, a good performance would be a tenth of a millimeter.
We've seen other solutions that are flexible, but they don't have a strong holding force. They hold on to the part more weakly, just enough to be able to grab it and then place it in another location, but you could easily move the part within the gripper. Other solutions that envelop the part and don't provide the accessibility that we need. We talked about magnets, and they're limited in, you know, by material. They'll work on steel, but not on aluminum. Other solutions which only provide a limited level of flexibility and maybe can grip a small, just maybe a smaller subset of the parts that we'd like to grip. Solutions that are sensitive to harsh environments, especially in cases where we have hot metal expulsion. And we've seen solutions that are very complex and would be costly. So these are some limitations that we've seen of existing gripper concepts out there. We don't feel like we've come across a solution that will really fully meet our needs. And so we're really looking forward to the solutions and the entries that will come from this challenge to really, hopefully show us something new that we haven't seen before, that might be able to solve this problem for us. And that is all I have, other than we have the schedule here. Fady, would you like to talk through this, or would you like me to go through this?
Yeah, sure. I mean, I wouldn't spend too much time on it because it's on our website. So we have a special page for the challenge. As you can see, I mean, basically we're opening the submission today, and it will stay open until the 10th of July. Then we will.
Fady, I can't hear you.
Fady, you dropped out. Yep.
on our website the link to submit for the application. You can go over it and see what kind of material will be needed. And then the shortlisted teams, there will be a couple of check-in kind of points from now until September, which is the due date for the proof of concept. So the shortlisted teams will be working with Pat, Miguel, and their team on developing the actual proof of concept. And then they will go through the installation in the actual environment. And then by end of October, basically, there will be the selection for the winning design. So this is in a nutshell the timeline that we have. And we hope that people have some time now with everyone staying at home and the lockdown. This was the kind of the rationale that it might make sense to launch this challenge now to make use of the time that most of us have.
Mm-hmm.
Okay. Do we have more slides, Pat?
No, we just got a list of, I've got a list of some links, and we'll also provide some additional references for folks to take a look at with examples of sheet metal components that they can look at. But that would be, I think, following the call today.
Yep. Yep.
Yeah. Do we have some time to go? And we got a bunch more great questions. I want to thank the audience too for kind of keeping all the questions flowing.
Let's go over these questions now.
Yeah. So one of the ones kind of correcting, I misinterpreted before. So when they were talking about IP, they were talking about like IP65, IP67, DUSI requirements, that type of exposure to elements. Is there any requirement from that aspect?
I think IP65 is regular industrial environment, if I'm not mistaken. I think IP67 is underwater. I think there's one that it's underwater, so I'm not very familiar exactly with which one with the number, but it has to be basically industry rugged and support the environment that you saw. I think it's IP65, but I might be mistaken. I'll look it up while we go into other questions.
Okay.
I think for this challenge, though, in terms of the proof of concept that would be developed, or for sure the initial submissions, we wouldn't expect that a proof of concept would be fully ruggedized. We would be looking forward to something that could be potentially ruggedized. That it's feasible that it could be ruggedized with some additional development. Our really end goal of this for the winning participant will be a proof of concept that we can demonstrate the gripping concept in our lab. And we're not expecting an end product at the end of this.
Okay. Is there any, how about the input power restrictions? Is it like 12 volts, or I think in the spec we discussed maybe individually it's powered by separate means, its own power.
Miguel, do you want to answer that? Or are you on?
Sorry, I was muted. So yeah, I'm here. Sorry, I was muted. So 24 volts would be preferred. However,
would that be limiting or no?
Well, 24 volts is what most robots give as an output. I think that for initial proof of concept, it could be 110. So it's something that you plug into the wall. If we had to prove it on a bench, or even for just an initial test. Mm-hmm. So bottom line, I don't think there's a particular, anything under 120 or 110 would be okay for a proof of concept. However, most likely the final solution would be operating in 24 volts.
Right, that would be something that's fully developed at that stage, and we're not requiring that it would be powered through the robot controller or something like that. At this stage, it could have its own external controls and its own external power source for our testing in the lab.
And actually, that brings a good point. I think that for the initial proof of concept, what we want is something that does not necessarily integrate or even doesn't integrate with the robot at all. We want to be able to mount it, prove that it works, you know, for the final version, and be in and out easy without much integration with the robot. Again, just for proof of concept and validation purposes, right?
Yeah, so this is more of a mechanical challenge from that aspect. Now, there's a question. There's a few questions about, you know, what's your target cost and quantity for a solution like this normally, or what you're looking for, or however you'd like to answer that.
Pat, you want to take on that one?
Well, I think I can get myself in trouble by saying a target cost.
Well, I mean, this
Yeah.
is a proof of concept, right? So, I mean, the target quantity at the end of this is at least one, right, for a proof of concept.
Well, I think that the proof of so I think the question has two answers. Well, more than two, but I'm gonna just give two. So yes, for the proof of concept is just one. However, you know, in terms of the potential for this, we have several body shops, thousands of robots handling parts. So in terms of if the question is how many N effectors does GM have, we have thousands of N effectors that could potentially be reconfigurable if an appropriate solution were to exist.
Miguel, is there a way to kind of, like you say thousands, is there a way to kind of get a little bit more estimate of that? Like, for example, on average, how many robots you have per manufacturing facility, and then we multiply that by how many manufacturing facility you have, maybe in the US or worldwide. Just to kind of rough estimate to get a sense of like how many robots or how many vehicles we're talking about.
Yeah, so I would have to dig into it. That's why, Pat, I think you might have a better grasp of this number, but I think
Yeah, I don't think we'd want to provide specific number, but there's specific numbers, and it may not be, it's probably not realistic that a solution will cover, you know, that one design will cover all of our needs because of the differences in the sizes of the parts and the geometries. But, you know, just for a rough number, our vehicle assembly plants would have, let's say, hundreds of robots, and throughout GM we have thousands of robots. And I think we could say tens of thousands of robots, but they're not all material handling robots. Some are welding robots, and some are material handling robots. So,
And it is fair to say that this is a common problem across the industry, right?
yes.
yeah, so we're not the only one that uses robots. Yeah, our competitors do, our suppliers do.
Or the custom grippers that you have.
Mm-hmm.
Yep, and it's important here to say, you know, reiterate that all the IP generated by you and by community as competition is still yours retained. So, so to the potential applicants, so you
Yes,
retain
it's
the IP.
retained by the applicants. Yeah, I know. I mean, this is a good point, Russell. So GM and us, we had a discussion about this early on, and we agreed that any IP generated, this is the participant ownership. And then, as I mentioned early on, if for the winning kind of concept, GM definitely is not looking to kind of take pictures with the winner and kind of hand the check. They're actually looking for how we can actually integrate this into their manufacturing process, or maybe get some investment, or kind of how to basically leverage this concept. So this is a real need. This is a real challenge that one of the largest automotive manufacturers in the country has. So there is definitely real business opportunity here.
Yeah, and just a note on the IP protection. I just would suggest that you just make sure that you have everything. You have your ideas protected before you, obviously, before you disclose them.
Yep. So there's a few questions here on. Will the entrants get written documents with details of the products to be handled? So I can take this, and then also another one. What kind of proposal? So after this session here, there will be a kind of a apply application Google form page that has a bunch of generic details that you need to fill out, but also including kind of any CAD models, any napkin drawings, anything you have, also like CVs or resumes to help kind of flesh out and understand, depending if you're academia or a startup or, an individual that or a bigger company, just to understand, who's entering, what you're submitting. So that will be up shortly after the challenge, shortly after the session. So there's another one about, can you talk about more details about the prize and the final evaluation?
Well, I think we have a $5,000 prize for the winner. And in terms of the final evaluation, what we'd like to do, and some of this is a little uncertain because of COVID-19, but we would like to evaluate the submitted design, as a proof of concept on we have a robotic cell in our lab that we would like to equip with this end effector and test it out in gripping parts for a specific application that we have. And so we would like to evaluate it in our lab, as well as looking at these other criteria that we've mentioned.
Yeah, I would add that the shortlisted team, probably we're looking at 5 shortlisted teams, and GM will provide some kind of financial support to build a proof of concept in the range of $1,000 US. But again, we intentionally made the design that, there is no kind of huge cash prize, because the actual recognition is being kind of able to solve this problem and have the opportunity to work with a company like GM into commercializing these kind of concepts.
Mm-hmm.
Okay. A few more technical ones. What's the life of your current end effector?
Miguel, do you want to take that?
So what could
how long do our end effectors typically last? They'll last the entire program, right?
Right. So usually it's 5 years, well, plus all the validations, more like 6 years. However, I think that given the flexibility of reconfigurable end effectors, what we would like to do is be able to use the end effector for multiple programs, so 10 or up to 15 years if possible.
Mm-hmm. And then there are conditions that can reduce the life of our end effectors. From time to time, we do have collisions, and there can be some significant damage to the end effector, and they need to be repaired or replaced because of that.
Yeah. I want to be respectful of everyone's time, and we reached the end of this kickoff event. I'm sure that there will be more and more questions. As we mentioned, there will be an email address on the landing page where you can send any question that you have. And also feel free to reach out to me or Russell or anyone in the team if you have questions. There will be a recording of this webinar online also if you want to go back and check some of the material we discussed. And the link for the application will be up if you want to get a sense of the kind of material that is requested. And again, the deadline for the submission of the initial concepts will be mid-July. The whole timeline will be posted online. So I would like to thank Pat, Miguel, and all the GM team. And we're looking forward to work with all the participants. Thank you, everyone, for taking the time to join us today. And let's conclude this and let's get back to work. Thank you, everyone.
Thank you, everyone.
Thank you, everyone. Thanks.